Alright, we're in good shape to keep going. Now let's blink the LED. So far we just parameterized the pins. We are not doing anything with that pin yet. So which functions am I going to use now to interact with the pin? You go back to your .c file. You can go down here until you find the functions. If you want things a little bit more organized, go inside of your header file, and if you scroll down you will see the functions that you have available inside of the .c file. You have here the GPIO read and write functions. These are the read and the writes. We're going to use this one over here. I go back to my main, copy that one. It has three parameters. The first one is the port, so we already know that we are doing the GPIO port D. Which pin are we talking about? We are doing the LED green for now, and then the bit action. If I don't know what to do for that bit action, hover, and we have a set and reset, so we're going to do bit set, turn on the LED. I'm going to copy that and do a reset, and then we need to have our delay so we can toggle the pin. How are we going to do that delay? We're going to create our own function. So I go on the top and create my void delay function here, and I'm just going to run a while that decrements a counter, and it does not do any assembly instruction inside. So hopefully it just takes I pass the end count, which is a number, and it just takes that amount of time just doing no instructions. I'm going to pass that one as an unsigned integer 32 bits, and it's my variable. And we're going to, for now, let's just use these, we call it this type, underscore IO. If I right click, let me see if I hover. If I hover, it tells you that this is the macro for the volatile word. We'll go over that next week. For now, I'll just put it like that. And let's go back to our delay. And now I can put my delay function here. And the question is, which value am I going to put inside of this delay? Well, we can do trial and error. We can put numbers until we see things working at the rate that we want. But we already know that our CPU on the video number 1 is running at 168 megahertz. So this is 168 megahertz. If my while instruction, if this while decrementing is just one assembly instruction, that means that if I run that at that speed, I'll get 1 second after this amount of time. So let's put that value here, 168, 123, 123, and same thing over here. Perfect. And let's compile, deploy the code, and let's run. And if you run, you will see that your board is going to have the LED constantly on. It's not going to be blinking. And that means that we are supplying more time than what you should inside of this while. Well, this while, in fact, this function over here, so calling this function, exiting the main code and going inside of the function and then execute the while, is more than just one instruction. We'll see on a different video how can we get, how many instructions do we have. For now, just believe that it is taking 10 ASM instructions, all these code. So that means if I'm doing 10, I need to reduce by a factor of 10. I need to divide this number by 10, so removing 1 0 in order to run this at 168 megahertz. So if I compile, deploy the code, and if you run, now you'll have your LED blinking at 1 second. Let's say now that I want to blink more than one LED at a time. So what do I need to do in my code? Because all the LEDs are in the same port D, my life gets a little bit easier here because I don't need to parameterize all these again. All I need to do is to tell that these parameters are going to be the same for the other pins. So how do I do that? If I go to these LED green, GPIO pin 12, and I right click, open declaration, you will see that this is this EXE value 0x1 and 3 zeros, pin 13 2, pin 14 4, and pin 15 8. Notice that these pins do not overlap with each other. So if I pull here notepad, I have my green, which is pin 12. In EXE is going to be this value for your register. If I write this in binary, I'm just going to write the 1 part because the other ones are 0. So I get 0 0 1. And if I go over my orange, I know pin 13, the register is this one, which is going to be this. And then you have the red and the blue, which is the 14 and 15, the 4 and the 8, 0 1 0 0 and 1 0 0 0. So notice that all the pins are all these pins are in different positions on this register. All I need to do is, if I want to set up these pins, if I do the OR operation and the bitwise OR, which is the straight line, I will get ones in all these places, and I do not jeopardize the positions of the other pins. So I go here, go to my main, and all I need to do is a bitwise OR, bitwise operation to my LED, let's say my red LED. And what else do I need to do that? I can affect these two independently on my while loop, or I can affect them at the same time by doing the same operation here, copying these and resetting, compile, save, and deploy the code. And if I press play or resume, you will have both LEDs blinking at 1 second.